let's get back into it. Hello and welcome back to another episode of Talking to Scientists. And today I'm joined by the oldest friend that has been on Talking to Scientists. I know Timmy from way back when we were in high school in upstate New York. But I will say no more. I will let him introduce himself and tell you a little bit about where he's from.
Sure. Thanks, Luke, and thanks for having me on. As Luke said, my name is Tim, Timothy, Timmy. Any of those variations is always fine. And I am from the next town over from Luke. I'm from Elizabethtown, New York. And so I spent the first 18 years of my life and graduated high school from Elizabethtown Lewis Central School. And then after high school, I went to the university at Albany, SUNY, so UAlbany. And there I studied computer science and applied mathematics with a minor in philosophy. And I graduated from UAlbany in 2016. And then I enrolled in graduate school here in Boston, where I am right now at Northeastern University. I am pursuing my PhD in network science from the Network Science Institute at Northeastern University.
So a couple things I want to clarify right there. The first one, you said you minored in philosophy. I had a computer scientist on recently who said that he minored in creative writing, and he hasn't been on one job interview where they didn't bring up the fact that he majored in creative writing and talk about that as like an addition to his skill set as a computer scientist. So was that something you did consciously, that you wanted to have like an other side to your major that was more less like data and science based, and to kind of make you more well-rounded? Or was that just something you just did because you were 18 and you felt like it would be cool to major in philosophy?
Yeah, that's a really good question. And so when I was going to college and trying to figure out what I wanted to study, I kind of had two competing interests. So one was the very practical of like, what am I gonna do for a job after I graduate college, right? That's like one of the motivations for going, was to be able to get a job. And so computer science is very practical. There's probably the industry is still growing. You know, we still need programmers in various jobs. You can make a good living right out of college as a software engineer or as a database administrator or other kinds of computer science work. So there was a practical consideration there for sure. So there was another side of what I was interested in getting out of my college education, which was more of an education for its own sake. So like a liberal arts education. And that's where studying philosophy really came in. I was interested in kind of getting these skills in critical thinking and kind of alternative ways to look at problem solving, and also a very historical view of what problems, you know, very smart people have thought were important in the past and how they approach them, and kind of where those questions sit today. And so, yeah, so those were kind of the competing reasons. There was the very practical, that I wanted to know that I was learning skills that I could translate into some kind of job after. And then also the kind of, I'm a learner at heart, and I wanted to study something that I felt like satisfied my curiosity. And that also has the side benefit of being, as the other person you had on mentioned, being of interest to potential employers, that, oh, like, that's interesting that you have this minor, like, can you talk about that? It's definitely a way into an interesting conversation during a job.
It makes you a little more multidimensional as a person.
Absolutely. Yeah, definitely.
Yeah. So the other thing that I wanted to zero in on that you just said was that you did your graduated from your undergrad in 2016, and then went right into a PhD program. The traditional route is to go bachelor's, master's, PhD, but you skipped over that master's section. How is that possible?
Yeah, so in the US, there's a lot of PhD programs that are that include a master's within them. And so mine isn't exactly like that. But basically, because PhD programs are 5 years, you can consider kind of the first 2 years of the PhD equivalent to doing a master's degree. And so in the particular program that I'm in, the network science PhD program at Northeastern, you do not need a master's coming in. And so rather than paying for a master's degree when I knew I wanted to get the PhD, I just went straight to the PhD, where I get paid to go to school and do my research and to teach.
That's awesome. What you didn't mention that before. You're teaching. What kind of stuff are you teaching right now?
Yeah, so I've only taught for one semester, and it was Zoom University. I taught in May and June. I taught algorithms, which is an introductory course in computer science.
Okay, awesome. So let's get into that a little bit and just talk a little bit about computer science, because I had a computer scientist on here recently who is not doing like PhD research work. He is doing more like back end software development kind of things, like developing programs and products for companies. So, as a PhD student, what are you doing with forensic science? And can you kind of explain that to us laymen, what you do as a PhD computer science researcher?
Sure, yeah. So the particular kind of computer science that I do is what's called data mining, or now it's more called data science. And so basically there's systems out there generating all sorts of different data. And the particular data that I'm interested in is network data. So things that connect. So you can think of social networks where people are connected by whether they interact. So right now, Luke and I, a line is drawn between me and Luke because we're interacting. And so these kind of social networks, or this kind of social network data, is one of the ways that is one of the kinds of data that we can analyze. But you can also analyze all sorts of different systems that have similar connectivity involved in them. So you can think of the entire postal service as a network of post offices, where when I send a letter to Luke, it visits a bunch of post offices along the way. And then we can analyze how efficient or inefficient is the postal service, why is it that way, and what could we do to change it, what kinds of other configurations might be better or worse for different reasons.
So the term network doesn't necessarily have to mean like a digital network, because when we talk about social networks, we immediately think of like Instagram, Facebook, where those are great metaphors because you actually have like friend connections and you have friends of friends connections. So that's easy to visualize a network. But when you say network in terms of data science, you also mean physical things, like how are groups of people or cities or other environments connected to, not just digital.
Exactly right. Yeah, exactly right. Anything that can be kind of viewed as a bunch of parts interacting with each other, you can model that as a network. So yeah, you're exactly right. And digital media networks are like the most explicit that we have in our lives. So
Yeah,
exactly,
most
it's a
notable.
really good metaphor for them. Yeah.
So what kind of networks are you doing research on right now? What data are you pulling and what kind of stuff are you trying to figure out?
Yeah, so one of my big projects is studying the network of global shipping. And so in this network, we take individual ports. So, you know, there's a port in Boston, there's a port in New York, there's a port in Los Angeles, there's a port in Shanghai, there's a port in Tokyo. And we want to understand how ships move goods and services, or goods, between these different ports.
Hmm.
And similarly to the post office example, we want to understand, you know, how efficient is the system, where is the system inefficient, and why, and also just broader questions of kind of how does the data about ships moving from port to port, what kind of insight can we get about broader economic questions of who's trading with who and why, and to what extent in the global shipping system.
So rises an immediate question for me, which I'm sure you'll have a very good answer for, which is it seems like you could do that type of data analysis using sales records of companies, or yeah, just sales records. Can't really get more specific than that. But why would you use the information of ships and ports and the comings and goings of the port rather than like a digital log of sales?
Yeah, so that's a really good question, and it gets at this idea of scale. At what scale should we measure the system that we're interested in? And so what you're thinking, I think, is at a more macro or a larger scale. So understanding how countries trade with each other. So who's importing what from who and who's exporting what to who. But what we get out of looking at the more micro scale, the parts themselves are a little bit smaller. They're ports rather than countries. What we get is a picture of not only who is interacting with who, but who is interacting with who through who. So kind of who are the intermediaries, who are the middlemen that are kind of routing the goods through the system, even if they themselves are not the largest, for example, economic actors.
Okay.
So there's different advantages to looking at a system like this at different scales.
Okay. So you get like much more granular detail, and you can
Exactly.
come to much tighter conclusions than you would just looking at the interaction between one giant organization and another giant organization. You get all this.
Yeah, yeah, sometimes, but also sometimes it's just more complicated. So
Okay.
sometimes it's for the better and sometimes it's for the worse.
Well, I guess if you're trying to draw conclusions about like shipping networks and how the world is created, it's going to get pretty complicated at some point. So
Absolutely.
yeah,
Yeah.
if you can rip all that data together and kind of figure it out, then you're doing all of us a service. So that's what you're working on right now. But is there anything that you have your eyes on in the future, maybe post PhD, the kind of other applications of data analysis, other ways that this could go?
Yeah, so I'm not exactly sure what I'm going to do next. So I'll probably graduate in about a year, and it's kind of an existential question for me of what exactly will come next. I could imagine continuing to work along similar lines, getting what's called a postdoc or a postdoctoral research position at a university or at a research institution, and continuing similar kinds of research. But I also have some other things that I'm kind of interested in. And so one example I can give is this idea of studying the movement of dust. So when dust gets kicked up in a desert somewhere, it often the tiny little particles get caught up in the wind and end up somewhere else in the world. So dust from the Sahara might end up in Europe. Dust from the southwestern United States might end up in the Northeast, in our communities. And as climate change progresses, and assuming that the average global temperatures are getting hotter, there's more desertification around the world, there's going to be more and more dust, and that dust is going to have implications when both in the places where it is very dusty and in the places where that dust ends up. And so understanding how this dust is moving around the world and what the implications are of that is another potential direction that I'm interested in going in the future if I could find somebody to fund me and pay me to do that research.
I'm sure. So my initial question was, is there other applications that you're thinking of for this? And you gave us an application, but that just made me think of more applications. So besides dust, you could look at how like pollutants travel. And like just most recently, we saw with the wildfires on the West Coast, over here on the East Coast, we could smell and like taste and see that smoke in the air. So that smoke across the entire country. So it makes you think about how does dust travel? How could pollutants travel? Um, and as there's like a shift in energy and traditional energies like petroleum and coal are less popular and there's a rise in renewables, there's also a rise in like nuclear. So we've heard about nuclear meltdowns. There's the Chernobyl HBO show. So like, could you potentially use your study of dust and your understanding of wind patterns to map pollutants or radioactive waste that has leaked and is traveling in wind currents? Could that be applicable, or am I drawing connections that aren't there?
No, I think that's totally applicable. Yeah, I think from my understanding of what happened in Chernobyl and various other nuclear meltdowns, yeah, I think part of what happens is the wind carries radiation, radioactive particles, and that's certainly something that if we had a good kind of methodology for understanding how dust moves, presumably we would be able to transfer that and also understand the way that the radioactive particles are moving. And similarly, we can think about water pollution, I think is also a very good example. So if we have, a company dumping some kind of plastic waste into a waterway, then we can try to understand, okay, we know that this is happening here or it already happened here. So where do we need to look downriver to figure out where the worst of the pollution is and the communities that are going to most need help dealing with that pollution.
And I just thought about this too. I'm sure there's a lot of network scientists like yourself who are doing research on the spread of diseases.
Yeah, absolutely, including myself to some extent. So, like I said before, I'm at the Network Science Institute at Northeastern University, and I've been lucky to be actually taught by Alessandro Vespignani, who is one of the foremost disease modelers in the world. And so network science, one of the kind of main subfields of network science is understanding the spread of things on networks. So disease is the one that's most kind of in our minds right now,
Yep.
because studying the spread of disease right now is extremely important, and understanding kind of what the implications are for what our models predict about where the disease might be next, or kind of how many cases we'll have. These kinds of things, they're important to us now in our day-to-day lives, whereas maybe a year ago that was totally unimaginable.
Yep.
But we can also think of happier things, like the way that the kind of purchase of fidget spinners spreads through a population. So, I have a fidget spinner and you see me playing with it, and then you go and buy one. And so we can model that kind of spread of ideas or information using very similar techniques to the way that diseases spread.
So it sounds like we're talking to you about a very like specific skill that you have, which is network modeling and prediction. But there are so many applications. It doesn't sound like there's an industry or a field that you could not apply these skills and these methods to, whether it be marketing or like environmental science, or your industry studying the shipping network. So do you think that there's a field right now that doesn't need network analysts or data scientists right now? Or do you think that if you could go into data scientists, you could probably do whatever else you wanted also?
You could definitely do a lot of things if you have the kind of skills that you get from learning how to model and analyze network data, or just data in general. There are some fields right now that, like 10 or 15 years ago, we wouldn't have thought or would be using kind of data analysis at all, such as, for example, English literature. But actually, there's now a subfield, admittedly a small one, of what's called digital humanities, which uses kind of computational tools to try to understand literature from a computational perspective. Now, that doesn't replace the importance of English teachers or of English literature researchers at all. It's just another way to look at similar information.
Very interesting. Yeah. And in another aspect of things that are not traditionally statistic driven, going in that direction, there's like a drive in sports now. There's some sports like baseball, which have always been very stat heavy, but now in sports like basketball and football, there's more and more analytics and data scientists making connections between certain events and different things, and drawing conclusions and changing the way that these games have been played. So not just changing the way that like the global shipping network can be played, but like what is the most efficient way to use this pitcher, or like how many minutes should this basketball player be on the floor, things like that.
Yeah, absolutely. And I can actually send you a kind of funny paper, but also I think a good paper that your viewers might be interested in,
Okay.
which is about analyzing the network of hockey fights. And
Oh,
so they basically analyze the role of enforcers in hockey fights. And it's a pretty, kind of funny tongue-in-cheek paper, but also they do a serious analysis of this. So I think that might be an interesting. Uh,
for people who are not big hockey fans, your enforcer is the person on your hockey team who's usually a big brawny guy who will fly in and hit somebody really hard,
yeah.
and to reinforce the idea that there's big people willing to hit you on the ice, and just put that thought in the back of your mind.
Exactly, yeah.
Yeah.
And the sometimes the kind of nicer version of their role is that they kind of get ahead of fights by kind of getting the people who are instigating off the ice.
Yeah, yeah. That's in the yeah. That's the chiller job description that they could
Yeah.
have. It's making me think of movies like Goon that I haven't seen that movie in a long time, but yeah.
Yeah.
So okay, so sorry, I don't want to get sidetracked too hard. Last question I want to ask you, and this is so for you can speak to anyone who maybe is interested in computer science or interested in data, or maybe they're not, and you kind of want to like rope them in. But why is what you do dope, and why should would-be computer scientists deeply consider going into this field?
Yeah, so it's a really good question. So I think there's a couple of reasons why what I do is dope. So one of them is that it's legitimately just scientifically very cool. And so the whole field, part of what I'm in is called complex systems. There's a lot of kind of understanding of very deep and interesting ideas using very simple and interesting models of them. And so I think that that's one of the reasons, is that it is just like the science itself and the things that it's trying to understand, like disease spread or information spread or hockey enforcers, all these things are just legitimately very cool. And I would also say there are like various reasons to get into or not get into something. I think I would encourage people not to be discouraged by, there's kind of a sense that, computer science and STEM, like they require you out of high school to know all these things. And unfortunately in college admissions, it might really look like that. But I can say from my own experience that I came into college as a computer science major without a really strong mathematics background, for example. And now I'm a fourth year PhD candidate in network science. And so I was able to kind of move up through that. I was able to get past some of the things that I didn't feel like I had going into college. And so just definitely want to encourage people, even if you sometimes feel a little bit intimidated, like everybody can do this. It's kind of like whether it's really what you're passionate about, what you're interested in. I think I encourage people to kind of follow those passions more so than kind of what they think they should do or what they're qualified for or any of those kinds of considerations.
That's awesome. Good advice. Well, Timmy, thank you so much for being here. I appreciate it. And I appreciate you running this interview twice because I botched the recording the first time. I think the second one came out even tighter, more concise than the first one. So thank you very much. I appreciate it.
Absolutely. No problem, Luke. Thank you for having me on.
Yep.